So let's do a sample problem, problem number 27. We're only going to do part A in chapter 8. So what we have here is we are given a potential energy function for either one of two atoms in a diatomic molecule that we can approximate with the following. U of x, U representing the potential energy, equals negative A over x to the 12th minus B over x to the 6th, where x is the distance between two atoms. So diatomic, that means two atoms, maybe let's say two hydrogens, and we're modeling the energy between these two atoms in this diatomic H2 molecule, and they're separated by a distance x. Okay, so how do we do this? Well, part A, we want to know at what distance of separation does the potential energy have a local minimum? And we want to get rid of and not consider x equals infinity. That's kind of the cheap way out. So we want to find out where is the local minimum for this function. And we can find minima of functions by taking the derivative and setting it equal to 0. So that's what we want to do. We want to find du dx, the derivative of the energy with respect to position, and set that equal to 0. So that's what I'm going to do. And I'm going to rewrite this function because I hate fractions. I'm going to put everything up into the numerator. I'm going to rewrite this by using negative exponents. So we have u of x equal to negative a times x to the negative 12. So this is the same thing as negative a divided by x to the 12th. I'm just raising it to that negative exponent to get everything up in the numerator so that I can use the power rule for doing the derivative. And then we're going to do the same thing to get the second part of this function, minus bx to the negative 6. And then I can take this derivative, and I can take this derivative fairly easily. Remember, we take the exponent down in front, we rewrite everything that's inside of the function, and then we raise it to the n minus 1th power. So that's, again, the general format derivative of x to the n is equal to nx to the n minus 1. So let's do that derivative. We'll do du dx is equal to negative 12 times the negative a times the x, and then I'm now raising this to the negative 13 because we have that n minus 1 when we take our derivative. And then we do the same process for the second part of the equation. Minus negative 6, bringing that exponent down in front, times b times x, and now it will be to the negative 7th because we're raising it again to that n minus 1th power. And this is what I have. I have my new function for the derivative of u with respect to x. It's going to be equal to 12a times x to the negative 13 plus, because the two negatives cancel us out, to give me 6b x to the negative 7. Now, I'm not done yet. I want to know the position where this function is a minimum. So to do that, I need to set this function equal to 0, set that derivative equal to 0, and find the value for x that I get here in this case. So I have 12 times ax to the negative 13 plus 6 times bx to the negative 7, and that's got to be equal to 0. So I want to solve this. I want to get all these things onto one side. I want to get all of my elements that have x onto one side and everything else onto the other side so that I solve this for x. So I'm going to move one value over to the other side. So I have 12ax to the negative 13, and that's going to be equal to negative 6bx to the negative 7. And here, I'm actually going to start writing these exponents into their fraction forms. I'm going to put them back into the denominators so I don't make mistakes with these exponent values. There are a dozen different ways that you could do this algebra. This is just one option. This is the way I'm choosing to do it. So I'm putting my x's back into the denominators. So now I can do cross multiplication to get my x's all on one side and get everything else over onto the opposite side. So I'm going to multiply both sides by x to the 13. And then I'm going to divide both sides by negative 6b. So this is just algebra that I'm doing. So that's going to cancel out my negative 6b's on the right-hand side, and it's going to cancel out my x to the 13 on the left-hand side, and I'm getting all of my x's on one side and all of my other elements on the opposite. So I have a negative 12a over 6b. That's going to be equal to x to the 13 over x to the 7. Now I'm dividing two exponents, so when I divide two exponents, that's the same thing as subtracting the exponents. So I have x to the 13 minus 7 is equal to now negative 2a over b, simplifying this 12 divided by 6. So I have negative 2a over b is equal to x to the 6th. Now to get x by itself, I need to raise all of this to the 1/6 power. That will give me just a plain x, but if I do it to the right-hand side, I have to do it to the left-hand side. So I raise the left-hand side to the 1/6 power. And I get negative 2 times a divided by b, all raised to the 1/6 power, is equal to x. So this is my value for x at my minimum energy.